So, 13, Alan, Rubens, and who else? I asked thank you. Thank you. You're welcome. Here. I suppose that the old smart belt. And your group members? Yeah, and last name W?
No, it's
So Alan is last name. The last one is so that's when we have the Yep. All right, so is that the last presentation for today for afternoon / half evening class?
Yeah.
All right, personally, regardless of the grades, whatever is going to get, I like this application. I'm very positive about it. And regardless of initial discouragement, sometimes, people will say, oh, no, that's not going to help. Or try to convert whatever negative or positive critique into what is your mission, what is it you are doing, why is it you are doing, and I believe that, over time you may overcome. I see lots of obstacles, but also see lots of advantages to make, good karma law. Yeah. I was saying about before you arrived, have any one of you been? I was talking about how I have a group of students and we applied for the conference and we did not get funding from our school. And then basically I wrote a letter back to the organizers apologizing and acknowledging hard work of reviewers, comments, critique, and that we agreed. And the first email said that the paper would have made a great contribution to E-Systems conference. So I said that's good enough for evidence of peer reviewed for someone's master thesis. But on the top of it, the next email was that the conference committee chairs, organizers, they agreed to let us free. We didn't have to pay participation for the conference and we could present our work online. So it's not, this is the first time in my life experience that something like that happens, so that's sorts of exciting. And maybe something similar may happen to your work, and someone will see that this, regardless of the outcome and critique, they will see that maybe you may get some sorts of re-invitation to the conference. Because we were working on a golf extraction of silhouette. Now think about who is your target audience? Elderly. Elderly incidents happen at any time. So you cannot hold their hands like they are little kids and they will not let you. When they go to toilet, they have more life experience on going on toilet than you have. So the sad thing is that toilet can be a death trap. Yeah. So they sit on the toilet after surgery, body no longer feels the same, and they fall on the ground, cold, hard surface, no one is there to help them. So that was pretty much aligned with anonymization of video, and I said, well, this is golf application for fun and extra games. but this can help to what you can also help. And that was really interesting experience that they said, we are waiving fees, please present it online for your system. So that's probably can be a good thing for your CV. All right, over to you.
It's not coming.
You just press HDMI if it's HDMI, or are you? Yeah. So you brand it as a spine saver.
Yeah.
Okay. Is this the same technology as smart belt, or?
Yes,
It's
it's same
same
technology.
technology, but we worked.
We done few changes on features and all.
Yeah. Spine saver, skiers, Formula racing car drivers, they have some sorts of
Motorcyclists.
Yeah, motorcyclists.
Cycling.
Okay, over to you. You are in charge now.
Good afternoon, everyone. The topic that we are going to discuss today is the spine saver. Let me introduce my team first. This is Ugly, Rubens, and myself, Pavan. So today, in our report, basically, we are focusing more on the current state of art with regard to physical fall experienced by individual person. So the factors that we are evaluating on basis of safety and security. Moreover, the elderly people tend to prone to accidents very easily. Considering the age and age factor in mind, they take longer time to recover more than like what we the middle-aged people actually recover from. So in a country like New Zealand, where the aging population is more compared to other countries, people tend to stay alone. So there's no one to actually take care of them, and there's no one to continuously monitor the activity. So in that case, for example, if such person who's staying alone just falls down and hurts his spine, it's very difficult for an elderly person to go to a nearest cell phone, grab the phone and notify to get a medical help. If the same scenario happens to someone like us, it's totally different. We are young and we can bear the pain and do something. So it's completely different thing when it comes to elderly people. So to overcome all these situations, we have proposed a device and we have named it as Spine Saver. And in the spine saver, we have few components such as accelerometer, Wi-Fi module, and microcontroller. And my teammate Ukli is going to talk over the architecture and the working of the bell.
So our architecture consists of 5 modules. First is the accelerometer module. In the accelerometer module, the accelerometer we place it in the center of the body because that's the center of mass for the whole body. So it calculates your tilt and acceleration at any point of time in 3 separate orthogonal axes, in all 3 axes. So, and the output from the accelerometer is electric signals. So the electric signals is passed to a data pre-processing unit, where the electric signals is first filtered to remove unwanted noise, and then it's passed to a low-pass filter to separate it into a separate AC component and a DC component of the signal. And then that is passed to a microcontroller. So what we do in the microcontroller is we calculate various parameters, such as using the DC signal, we can calculate the posture of a person, whether he's standing, sitting, or if he's lying down, if he's lying to the left, to the right, facing front, backward. And using the AC signal, we can calculate somebody's energy expenditure during when they're walking or when they're running, or the energy that they expend at any point in time. And also, we calculate the acceleration. So when a person's acceleration is around 1g, it's like he's just walking or just sitting or something like that. When he's running or when somebody's jogging, the acceleration can go up to 5g, 6gs. So we took a threshold limit as 2.5, and anytime acceleration peaks to like twice the threshold limit, more than twice the threshold limit, we consider it a fall or a stumble or a collision, something that peaks acceleration in the person. So when a fall is detected in the microcontroller, we use Atmega 16. So when it sends to
Arduino based.
Arduino based.
Or
yeah.
we can call it
Arduino
almost
based.
like Arduino compatible.
Yeah. Arduino compatible. And so it sends 2 signals, one to the inflation module and one to the Wi-Fi module. The inflation module inflates the airbags, inflates the nylon bag present in the belt, and the Wi-Fi module sends an alert, like a message. So let me explain, to make this part more clear, I have a real-time example, when a person falls. So when a person is in high acceleration, as in running or something, or when it's a fall, the acceleration is at its peak. So there are when acceleration is high, it can be normal activities such as running or jogging, or it can be a fall. So when it's a fall, the microcontroller sends a message to the inflation module and to the Wi-Fi module. In the inflation module, ignition is caused using an igniter, which we're using a solid propellant called sodium azide. So when sodium azide burns, it gives out nitrogen gas very quickly. It explodes nitrogen gas, and this nitrogen gas inflates the nylon bag, and this all happens within a blink of an eye, fraction of a second. And simultaneously, an alert is sent from the Wi-Fi module to a family member or someone who's registered with you. So a message is sent to them saying something's happened, there's a medical condition and thing. So what we did is we gave them a 60-second buffer limit. So within 60 seconds, if that person who received the message deactivates the alarm, so it's deactivated. In case they don't, if it's a false alarm, they can deactivate it. In case they don't deactivate it, the Wi-Fi module sends a message to a nearest hospital, a registered hospital or an ambulatory service, asking for assistance, asking for medical assistance. This is after a 60-second buffer limit. So this is what happens when an actual fall is detected. So now my teammate Ruben's going to talk about what we achieved and what we are actually planning to do in the future.
So during initial stages of the study, we realized that this device could only be used by elderly people who don't have constant monitoring. But as we progress, we realized that it can be used by elderly people, but also by the differently able, pregnant ladies, and also motorcyclists who are prone to extreme injuries in most cases. So the components of this device, we are going to use lightweight components, because since if everything's heavy and since it's a daily use belt, in the long run it causes spinal deformities and it's just a burden for the user. And in most cases, this everyday device will act as a lifesaver in certain extreme situations, such as a sudden fall from extreme heights. And in the future, we'd like to build a prototype and test it out in a real-time environment and check if this could be put to commercial use and help save lives and prevent injuries. And we had certain limitations, such as the airbag system. Once it's deployed, it has to be serviced. So in the future, we'd like to make that airbag system to be just folded back and reused by the user themselves. And in some cases, when we fall from heights such as more than 10 meters, the airbag tends to burst. It will prevent a serious injury, but you will still get injured on a certain level. So what we plan to do is make the capacity of the airbag to withstand falls greater than 10 meters. And finally, we like to, once the airbag is deployed, it covers the lower part of the spine and the hip. But you're still prone to face head injuries, and the upper part of your spine is still prone to injury. So we'd like to increase the capacity of the airbag to save, protect the head and the upper part of the spine. Thank you. And any questions, please?
Yeah. I experienced once high velocity fall, and it had stages as far as I remember, because at some point I lost conscience, but it was like flying, going, and then you start rotating very fast, and then you open, and then you start hitting, bang, bang, bang. So when you are lucky to hit legs or with head, you have that sort of like different rhythm of hitting the ground. And I'm not quite sure what happened, but at some stage I remember I was trying to squeeze to rotate as much as I could, and at some stage I couldn't, just so I went into that second stage of hitting, but I still had horizontal velocity, which is friend when it comes to that rotation. And then somehow you ended up, I don't remember all the other details. So combined with helmet and legs, I think that there is more applications into protecting hip region, not just spine. And also allowing certain flexibility. So we have at AUT fashion design. They would be interested to support you. I mean, I could organize if you want to follow up with a master thesis or more serious work of a PhD.